This is Danny Tang. I'm doing the probability and stochastic processes homework 9, problem 1. Problem 1 gives us z of t is m1 of t cosine omega c t plus theta plus n2t sine omega times t plus theta. Part 1 wants us to find the expected value of z, and we can just put the whole expression of z of t into the expected value, which is, you just write this whole expression in the brackets, and then we can separate these into two expected value expressions because of linearity. And since the problem gives us n1 of t and n2 of t are WSS, that means that their expected values are constants. So we could bring those out. We can separate this out into expected value of n1 of t times expected value of cosine minus expected value of n2t times expected value of the sine. So since these two are cosine and sine, the expected value of these two parts will go to 0. So that means that this whole expression is 0, and that means the expected value of z is 0. So part B asks find RZ T1 T2, and then asks if z of t is WSS. So RZ of T1 T2 equals the expected value of z of T1 times z of T2. So to do this problem, we just put z of T1 times z of T2, so you get an expression that, you get the same expression, but you use T1 for one part and T2 for the other part. So if you do this expected value, you just FOIL this out, you FOIL this expression out, and what you get is this really long expression. And we can simplify this using the trig identities, which I won't go into, but it can simplify into this long expression here, this block of expression here. And this is really easy to simplify because because you can cancel out some of these parts, and you know that the cosine expression here goes to 0. It goes to 0 here. It goes to 0 in the sine expression and here as well. These two parts cancel out because of opposite signs. So all you're left with in the end is essentially this part, expected value of cosine times omega c of T1 minus T2, and the same one here. But the main thing to remember is that don't be careful when doing the signs. And you can write T1 minus T2 as tau. So then what you're left with is 1/2 R1 T1 minus T2, which is this expression here, expected value of n1 T1 n1 T2, times the cosine here, minus 1/2 R2 T1 minus T2, which is this expression, expected value n2 T1 n2 T2 times cosine, which is this expression here. So once you replace tau, you replace T1 minus T2 with tau, you get this expression, 1/2 R1 tau cosine omega c times tau minus 1/2 R2 tau times cosine omega c tau. And this means that z of t is WSS because it's not dependent on t. And for part C, it just asks us to find RZ as 0 with, so you just put 0 where you see tau. So you just get this expression here, the cosine of 0 is just 1, so in the end it simplifies to 1/2 R1 0 plus R2 0.